A rectangle has perimeter P and area A. The values P and A must satisfy one of these options. Okay, so for one thing, the first thing that comes to mind here actually, beyond any geometry, is just unit analysis. Options A, B, and D can't possibly be true because the units on each side are not consistent. Perimeter is going to have units of length, and area is going to have units of length squared. So in option A, P cubed greater than A, on the left-hand side, you have the cube of a length. On the right-hand side, you have the square of a length. So these things are not comparable with an inequality. Similarly, in option B, on the left, you have area squared. So that's going to be length to the power of 4. And on the right-hand side, well, adding 1 to something that, 1 is dimensionless and P has dimensions of length. So this expression doesn't even really make sense on the right-hand side. You could argue that we're using unitless lengths and areas or something like that, but these types of things have to be kind of consistent with a change in units. And so by adding 1, if I change the units of length from, say, centimeters to inches, the 1, how does that change? Okay, so option B doesn't make sense because you have different dimensions on both sides, and option D doesn't make sense. On the right-hand side, area plus perimeter, again, these have different units, so they can't even be added together. And on the left-hand side, P times A will have units of length cubed. On the right-hand side, again, it doesn't make sense, but whether it's length squared or length, it's not comparable. So the answer here is going to be C. P squared is greater than or equal to 16A. If we wanted to see this more directly, the shape that maximizes area, if you have a rectangle with a fixed perimeter and you want to maximize the area, it's going to be a square. So each of these side lengths is P over 4. So the area is going to be P squared over 16. And so this gives us 16A is equal to P squared. But this is the relation between perimeter and area when we have a fixed perimeter and we're trying to maximize the area. So the area will have to be, in general, something smaller than P squared if the rectangle isn't necessarily a square. Yeah, so a couple different ways of seeing how to do this one, but my first instinct was to notice that the units of all 3 options other than the correct one don't even make sense, and so we can eliminate those right away. If I have more to say, I'll put it down in the description. Thanks for watching.